inspiring action. You tuned in network. Turn up your volume.
All right. This is Shenga, your host of SG2 on Space, as always, the only weekly space radio show. Sorry, can't talk right now. Here in Houston, Texas. Of course, broadcasting on the interwebs across all of space and time, I hope. So it doesn't matter what century you're listening in or where you are. So, as long as you tune to facebook.com/Action1Media, or we are a1, the number one.com, or the associated YouTube channel, which I will give you a later point because I can't remember, or facebook.com/The Shen Show, the old name for SG2 on Space, you will be able to catch it. All right, and of course, we also have a phone app as well, Action One Media. So, in any case, so this is episode 20, and wow, it's been a while. Been doing this weekly, pretty much, except for holidays like Thanksgiving week and Christmas times. So, speaking of holidays, happy Chinese New Year or Lunar New Year. Sorry, don't want to offend any Koreans or Vietnamese folks or whatever else. But yeah, so that's pretty much celebrated, like 2 billion plus people. Not so much on this side of the continent, but in any case, yeah. That aside, it's I don't have any space news on pigs or anything because it's the year of the pig. Although I could go into astrology if you want, Chinese astrology. I'm not going to. That's not the point of this show. Let's talk about real science. How about that? Okay. So with that statement, let's talk about the Earth magnetic pole because we're going to start close and then move out far. So apparently Earth magnetic North Pole is moving super fast, and nobody really knows why it's moving that fast. It's moving so fast, in fact, that we have to update the magnetic map, all right? there's a couple of magnetic models. One of them is called the World Magnetic Model. Another one's called IGRF, which is basically pretty much you can think of it as the equivalent. And then lastly, there's much simpler models, all right? But for the sake of precise measurements, for instance, military purposes, or NASA or FAA, U.S. Forest Service, any kind of GPS. So yes, that affects you as well for us navigation, for everyday people. We need a very accurate magnetic model, and hence that's why there's an urgent need to update it, because nobody expected it to move so fast, right? So to just give you a quick overview, we're going to play a little video that basically shows in graphical form what I'm talking about, like what is Earth's magnetic field, and what is happening. So
getting her a gift card for Valentine's? That's like giving her a bag of grapes and saying, here.
Before we start playing the video, that this is basically Earth's magnetic North Pole is never constant, all right, and it's updated every 5 years. But this latest change was completely, really unexpected. So let's see what happens when this video comes up. Such a beautiful picture of Earth.
It is making its way. Thousands, NASA announced the pole changes to Earth's magnetic field are tracked with the World Magnetic Model.
Enough with this person talking. Honestly, watching it on my own computer, she sounded more interesting. But now listening to her, she sounds like a robot, which with no intonation. I wonder why she racked up like 50,000. No, it's like 90,000 hits on YouTube. Amazing. For something that came out a week ago. All right, I don't know. Eventually, this radio, Action One Media, SG2 on space, I'm gonna hit like 1 million views, right? So, all right. So forget this lady talking in a very boring manner. I will just talk about it. Essentially, what is happening is that Earth's magnetic North Pole is moving. Now, why is it moving? Well, Earth core is very complicated. All right, and Earth core, in case, just give a quick lesson. It's molten, but it's not just molten rock, it's molten metal. We have an iron core, okay? And iron, if you guys know, could be magnetic, right? So, since the Earth core is like, it's moving this way and that, the magnetic field around it, like, which extends beyond, all the underground, or like extends way beyond our atmosphere, that is also moving, right? And so, it's in every magnet. There's a North Pole and a South Pole. And so when the Earth little churning interior metal iron core thing moves, it's liquid, right? Then that moves the pole as well. So it's very complicated. There seems to be 2 large-scale patches in the magnetic field, one beneath Canada and the other beneath Siberia. If you ask me why it's there, I would tell you I'm not quite sure. And why is the Siberian patch winning this current like tug of war? No idea either. That's why these geophysicists are investigating it, right? When worlds collide, hopefully let's play this little video. So quick intro is scientists looked at this alien star system, I should say, in Kepler 107c, and they seem to be about the same size, and they're in the same star system, but apparently there's a huge amount of difference between the two, and this is likely caused by a giant impact that stripped away a lot of the mantle from one of the planets. So And this was, like I said, these planets were originally detected by Kepler Space Telescope using a transit method, which basically looks at, you know, I think I've shown this before. Light hitting me in the face, right? Let's just say a planet crosses it, it dims the light a bit, right? So I'm an observer, I notice there's a dip in the light. So astronomers can see that, you know, with sensitive enough instruments like the Kepler Space Telescope. And so then you can say, oh, there's a planet this size that's crossing in front of it. And through other theories, you can figure out the mass, right? But then we had a more accurate model by using what's known as a radial velocity method, which basically tracks the little wiggles in the star's movement due to the tug of a planet's gravity. Now, this is minuscule, but if you have enough tracking, take enough measurements, you could actually do it. So you can better estimate a planet's mass. All right, and then you combine these two types of measurements, and you know, this is what you see, right? So, in any case, this video it's not so much about that particular planet, but it does talk about what Kepler has enabled us to see, the telescope, not the person. So, watch a short look.
There's a life out there.
Of molten rock. We see planets that are orbiting not one, but two stars. That is, if you look in the east, you'll see not one star rise, but two.
It's fiction. That's why a lot of them got into the business of looking for planets in the first place, to find out if any of this, you know, fantastic speculation that inspired us could be true. And now we find out that, yeah, it could be true.
We learned from Kepler that the most common types of planets in the galaxy are unlike the planets in our own solar system. These worlds are intermediate in size between
are diverse. The stars that we find planets around are diverse. The systems that planets live in vary widely.
It was breathtaking to see.
Typically, we've got 2 commercial breaks. So, summarizing it, you know, through these measurements, they discovered one of them had a giant impact. Now, it turns out this is fairly common, so imagine that. And we've experienced that here in our solar system with Mercury's huge core. Similar compositions are Earth and Moon. Yes, the Moon formed from some giant object hitting Earth. And Uranus is tilted sideways. So, with that comments, we're going to go into break, and when we come back, I want to talk about dark energy, because that's fascinating.
Action 1, inspiring action.
So I challenge you today to start strong.
Start the revolution. When we turn up, we shut it down. We are skywalkers. The spheres of my Kabbalah illuminated properly in sight. Shows the man in universe and the creator's gift of life. When the earth collides with every piece of star from afar, there's a higher probability of...
Join today. Get in the action at weareA1.com.
Everybody say, get in the action! Get in the action!
Well, he dabbing on him, okay. Get in the action!
Yo, we in here dabbing on the real. Y'all stay tuned, more to come. Action 1 Media Group. Time to get into action, man, for real.
In your face.
All right, this is Shen, and I'm back. So you have been listening to, and this is still episode number 20, SG2 on Space, the only weekly space radio show here in Houston. I'm assuming you're listening to us on Facebook.com/Action1Media, or weareA1.com, 1 as in the number, or Facebook.com/The Shen Show, or the app for Action 1 Media, or our YouTube channel for Action 1 Media. So, any of those. All right, so before we went on break, I was talking about Earth's magnetic pole moving around and 2 planets hitting each other. That was recently pretty much confirmed in how one of them was formed. Something hit it. All right, that was in a distant star system tracked by Kepler. And now I want to talk to you about something even crazier. So, dark energy. Now, what the heck is it? Well, scientists first proposed the existence of this invisible force about 2 decades ago. And of course, it was so revolutionary that the folks got, researchers, 3 of them, got Nobel Prizes back in physics in 2011. So, according to the most popular astrophysical models of the universe, including its past, present, and future, we have regarded, well, scientists, not me personally, scientists have regarded, cosmologists, I should say, have regarded dark energy as a constant. In other words, it's just a number and it doesn't change, all right? And many astronomers believed it to be equivalent to the cosmological constant, which, for lack of a better term, is a constant that defines how rapidly the universe is increasing in terms of its acceleration. Universe is expanding, right? But how fast it's expanding? Well, that depends on the cosmological constant. So that is actually originally part of Einstein's theory of general relativity. So now, what is different now than before? I mean, come on, we must have known dark energy is some number, right? The cosmological constant. Well, what's different now is that we have new observational data, okay? And this new observational data does not seem to line up with theory in terms of the fact that dark energy is constant. So let's watch a little bit. This was first uncovered, by the way, by the Chandra X-ray Observatory, which observed very distant X-rays from these things known as quasars, which are really ancient. You can think of them as galaxies, extremely ancient. If you go backwards in time to, like, say, 1 billion years after the Big Bang, quasars, that's what we're observing, okay? We're observing something like in the first 1 billion year. I know you think 1 billion years is pretty long, but in universe time, I mean, we're at 15 billion years now. So 1 billion years right after the Big Bang, these quasars are immensely energetic, and we can still see their light. And, we can, based on that data, we can determine the universe's expansion rate back then compared to today, and then see the difference, right? And then, there's some complicated math and see that. So let's watch a little video about what these Chandra X-ray Observatory folks were saying.
A pair of astronomers has found evidence that dark energy may vary over time. If confirmed, this result could force astronomers to re-examine their fundamental understanding of the history and structure of the universe. This new study uses X-ray data from NASA's Chandra X-ray Observatory and ESA's XMM Newton, along with optical and infrared data from the Sloan Digital Sky Survey. First discovered about 20 years ago by measuring the distances to exploded stars called supernovas, dark energy is a proposed type of force or energy that permeates all space and causes the expansion of the universe to accelerate. While the exact nature of dark energy is unknown, many astrophysicists think it is constant throughout space and time. The latest result involves the development of a new method to determine distances to quasars, rapidly growing black holes in the distant universe that shine extremely brightly. This method, which uses data on about 1,600 quasars, allows astronomers to determine distances to quasars that are much farther away from Earth than the observed supernovas. The astronomers observed quasars back to just 1 billion years after the Big Bang, and found that the universe's expansion rate up to the present day was faster than expected. This could mean dark energy is getting stronger as the cosmos grows older. This is a new technique, so the researchers took extra steps to show that this method gives us reliable results. They showed that results from our technique match up with those from supernova measurements over the last 9 billion years, giving us confidence that our results are reliable at even earlier times. Still, more research is needed to confirm this exciting result. The researchers plan to use a large sample of Chandra observations of quasars at a wide range of distances and apply this same technique.
Alright, so that's pretty neat, right? So, yep, now, well, so what does this mean? Well, according to the researchers, so this apparently accelerated expansion rate compared to that early universe leads some scientists to suggest that new physics might be needed to explain this discrepancy, including the possibility that dark energy is growing in strength. And these results suggest, actually agree with that suggestion. So even before this experiment, there were scientists that posited that dark energy could be changing in how strong it is. So, yeah, crazy. Now, we can continue and talk about the wild, beyond, great unknown, but I figured let's talk about technology a little bit. What's going on with these crazy, I would call them space cowboys, given that's something an associate of mine has said. Namely, well, I'm not going to name any names, but yes, let's keep it at that. All right, so first of all, let's talk about SpaceX. Now, everybody's heard of SpaceX, right? Company made by Elon Musk, wants to go to the Mars, moon, blah, blah, blah. All right, so just a quick update on what's going on with that Tesla rocket, not Tesla rocket, Tesla Roadster, the car that was launched into space last year, is pretty much like a gimmick. That was about a year ago, actually, on February 6th. That's when SpaceX's Falcon Heavy rocket basically did his maiden flight and launched Elon Musk Tesla Roadster with a mannequin driver called Starman into orbit around the sun. So where is it now? Well, it turns out it's beyond Earth orbit. In fact, actually, no, it's not just beyond Earth orbit. It's beyond Mars orbit. It moved beyond Mars orbit in early November, and it's out there now more than 226 million miles away from Earth. And there's a website, amazingly, called whereisroadster.com. And Roadster is spelled ROADSTER.com, which essentially tracks where the Starman car is, which is pretty cool. You can go check it out. But point is, it follows elliptical orbit, which basically means that it does come back to, to within the to near Earth orbit at its closest solar approach. So, all right. So, is it eventually going to hit Earth or something crazy like that? Well, there is a probability, but that will, it has like a less than 3% possibility of hitting either Earth or actually no. Let me correct that. According to scientists, some people who've looked into this, there's a 6% chance that it will hit Earth within the next million years. And there's 2.5% chance they will hit Venus. So, wouldn't that be great if you get hit by a Tesla that was launched last year? No, it wouldn't, but I think it'd be funny. It probably wouldn't happen. All right, so on to that note, I thought it would be funny to get hit by a mannequin driving a Tesla Roadster. That'd be fun. All right, so on to more important news from SpaceX. As you know, the next step is going to the moon, right? Remember that back in September 2018, this Japanese guy, billionaire art collector, he was chosen to fashion design art curator Yusaku Mazawa, and he wants to go around the moon, and he was basically chosen as going to be the first human that's going to ride in the SpaceX new rocket. Well, for Elon Musk and SpaceX, that thing's moving full speed ahead, let's just say. So they have fired, and Elon has shared this on Twitter. So they have started test firing its powerful new Raptor rocket engine, R-A-P-T-O-R, Raptor rocket engine. And they're also concurrently building the company's Starship vehicle. And by the way, both of these are being developed in Texas, so wonderful. On February 3rd, which is, fairly recent, there was the first firing of the Starship Raptor flight engine, and it was quite impressive, I say that. So, now this engine mostly uses methane as a fuel, which is similar to another aerospace company called Blue Origin, which is founded by, once again, another billionaire, Jeff Bezos, the founder of Amazon. So Blue Origin's BE-4 engine also uses methane. So why are we all using methane? Well, because it's easier to deal with and it's cleaner than traditional rocket fuels like kerosene, for instance, right? Also, Elon Musk eventually wants to go to Mars, and a bunch of other people want too. And Mars has way more methane than kerosene. I mean, yeah. So basically you can use in situ resources, in other words, native resources on Mars, somehow gather the methane and use that as fuel for your rocket engine. Take it back to Earth, right? Or wherever else we go from Mars. All right. So how many Raptor engines are going to be on the Starship vehicle? Take a guess. Is it 1? It's not 1. Is it 50? It's not 50. Is it 20? Nope, it's not 20. Why am I guessing for people? I'll just say it. It's 7, all right? There's 7 Raptor engines that's going to be used on the company's Starship vehicle. And this spaceship, which, like I said, is also currently in development, will be able to take 100 people. That's amazing. To the moon, Mars, or even beyond, all right? So, now, these 7 engines are on the actual spacecraft, but what about the rocket that's going to be needed to loft this gigantic spacecraft into space? I mean, into Earth orbit, we'll just say. Well, the Super Heavy booster is going to have 31 Raptor engines, which is a lot. All right, so that is that's going to be quite something. And that's going to be test flighted in 2020, the Super Heavy booster. So you can see, SpaceX is working on a bunch of stuff like the Raptor engine, the Starship vehicle, and the Super Heavy booster, which requires the Raptor engines, right? So technically, I mean, the Starship vehicle also does too, but that could be done at the same time. So in any case, now currently, we're still just testing the engine on the test stand. Now, flying it is a whole different ball game, so we'll see what happens there. So when's this Japanese guy Yusaku Mazawa flying? Apparently, according to reports, 2023. So after that, it is on to Mars and beyond. So let's see what happens. Now, more conventional bases, while this is being developed, we are continuing operations of SpaceX's existing fleet, which has the Falcon 9, Falcon Heavy, and the Dragon spacecrafts, all right, which have been taking cargo up and down to the space station. So now, later this year, there's going to be a human-rated Dragon, which is going to take astronauts to the space station. All right, so it could be as early as this summer, which would be amazing. I mean, finally we have commercial capabilities again. America has been dependent on the Russian Soyuz for the last number of years since the space shuttle retired to take humans to the to the space station. So this would be great. So, all right, but of course I'm more excited about going to the moon and Mars and such, right? So that's the main thing to me, at least my perspective here. One step at a time, that's the thing about SpaceX, right? You work on what is happening now, what is happening in the near future, and then you work on stuff that's like a few years down the line or beyond, which is a pretty cool way of thinking things. So, yippity yip. So, any case, with that, Now, I've been talking about the moon a bit. It seems like there's a lot of interest in the moon, right? So we, as I mentioned before, the Chinese has a lunar lander / rover there. Well, it turns out NASA has recently spotted the lander, and so NASA had this thing called the lunar spacecraft called the Lunar Reconnaissance Orbiter, which has been pretty much going around the moon forever. I should not say forever, since 2009. So 2009, is that forever? That's been like 10 years now, which is, pretty darn good for a spacecraft in terms of its lifetime. So they took some good pictures and essentially, photographed it. Now, there are like 2 pixels in this picture. So you can see, like, the moon's small, but it's still huge compared to, a human lander. So, anyways, this was photographed on January 30th. Anyways, the size of this lander is about a car. It's gonna be about 12 months. It's gonna last about a year on the moon's far side, which is the lunar face we can't see from Earth. Hence, the dark side, which is really a misnomer because it's not always dark there. It really should be called the far side of the moon. Anyways, now the LRO, the Lunar Reconnaissance Orbiter, was unable to see the the rover though, because it's much smaller, and that's about the size of a desk. So it saw something the size of a car, but it couldn't see the thing the size of a desk, which is fine. I mean, anyways, so the rover, the little rover that went off from the lander, is supposed to be able to last a couple months. All right, so and it could navigate and see what's going on, see what we discover on the moon. Maybe we'll discover alien artifacts. That's always my thinking, right? So aliens. That's where I constantly go. That's where my head goes. All right. So, but really now, we even if we don't just cover aliens, I'm sure we're going to discover a lot about the formation of the moon, which, considering the moon has has no erosion, its rocks and soil will pretty much reveal the state like a couple billion years ago when the solar system just formed. All right. And the South Pole Aitken Basin especially is the largest impact crater in the solar system. And so below the surface, you could really see back into history for our solar system. So that is indeed wonderful. So any case, speaking of life, actually, I saw this article recently, which talked about, going off to other star systems, right? Okay, so we talked about, hey, like SpaceX goal, right? Go to moon, go to Mars. Well, especially Mars, right? So Chinese goal, go to moon, right? And other nations as well, like Europe, for instance. I think I talked this a little while back about building a moon village. Which sounds wild, but hey, maybe we'll happen in the future. But how big should a spacecraft be to take us to beyond? Say we go to Alpha Centauri or some other world, right? Maybe that Kepler world that I mentioned earlier. Now, since currently we don't have faster than light travel or anything even close to the speed of light, it's going to take us years, like hundreds of years, to get to even the nearest star system, which is Alpha Centauri, right? That's like 4 light years away, and it's going to take us at least 100 or 200 years to get there with our current propulsion technology. And for humans, that is. All right, so the scientists by Dr. Frederick Marin of the Astronomical Observatory of Strasbourg and Dr. Camille Baluffi, I'm totally not saying the right name, particle physicist with the scientific startup Cascade, I guess it's Cascade, and Dr. Rice Taylor of the Astronomical Institute of the Czech Academy of Science, and Dr. Lloyd Grant of the structural engineering firm Morphoscene. So yeah, truly international effort here. So they basically investigated how big a ship needs to be for it to be able to carry generations of humanity to some other world. So these are known as generation ships. All right, so generation ships is basically you get on the ship and you know that you're not going to make it. Your kids, think of it as like Noah's Ark, except through space. All right, so you're not going to survive the flood, so to say. Well, except I don't know if Noah survived. Okay, that point aside, it's your kids and your grandkids and so on and so forth who eventually, you know, be the folks who actually settle the whatever star system that you originally planning to go to hundreds of years ago. All right, so in any case, this idea has floated around for a while. So, but nobody has looked into how large the spacecraft would need to be. So from their analysis, they determined that a minimum of 98 people would need to be there without the risk of genetic disorders. No, you don't want to marry your sister, right? That would be weird. Without risk of genetic disorders and other negative effects associated with intermarrying, right? So then the question arose of, okay, so we have about 100 people. Now, what about feeding the crew, right? Since we can't bring like 1,000 tons of crackers or whatever else with us, you know, so we can't do like our current space station, and we can't do it like you know, maybe we'll grow food on Mars, on the moon, but, you know, like there's not that much space on a spacecraft, right? So how do you want to optimize the amount of space you have to grow food? So what do? They use this equation called the Harris-Benedict equation. Harris-Benedict equation to estimate an individual's metabolic rate, all right? Which I don't know much about biology, but that seems pretty cool that you have a method to estimate somebody's metabolic rate. So, and so they evaluate how many kilocalories must be eaten per day by a person in order to maintain the ideal body weight. All right, and then they included weight and height variations. So they put through some statistics in there to account for realistic population. You know, it's tall, small people, heavy, light. All right, so once they estimated that, they computed how much food geoponics, hydroponics, and aeroponics farming techniques could produce per year, per kilogram, not per kilogram, per kilometer square. So, and then they compare these numbers with conventional modern farming techniques. So, so what did they discover? So they discovered, oh yeah, they also had some architectural constraints for the minimum size of the generation ship itself. It has to generate artificial gravity, and the only way we know to generate artificial gravity is by spinning a thing around, like you see in those movies. Like, have you seen The Martian? Just one example. So once again, we're not using any exotic technologies that we don't know yet. All right, we're just spinning the thing, creating artificial gravity. And so with that, with a rotating cylinder, and with all the information, as I just said, for food, they discovered that you need something that's pretty large, all right? So you would need a minimum about 224 meters in radius. So from the center here, so rotating 224 meters, right? All right. And 320 meters, which is like over 1,000 feet in length. So humongous. But at least we have a number now. Previously, we had no idea, right? So this is good. I'm glad somebody's thinking way out into the future. Some people, I should say. So there still remains the issue of water. So humans, I need to drink water, right? That's why I was drinking this before. If I don't drink water, I'm going to die pretty soon, right? So in fact, water is even more important than food in some ways, in a lot of ways. So we're going to need a lot of water, not just for drinking, but also for irrigation. Yes, you need water to grow some plants, unless you're doing aeroponics. And sanitation. And it's not enough to simply rely on recycling methods, right? You know, you still need to have extra water. So that's going to add more space. That's something they haven't calculated yet. So they're going to do that. And once they do that, the spaceship might be even larger, in which case, you know, that'd be interesting. Yep, so now, given a chance, would I go on one of those ships knowing that it is going to a different star system and I would never see it, but my kids might, or kids? I might, if I'm willing to stick myself in a giant floating box for the remainder of my life, I guess. Actually, that doesn't sound that pleasant. All right, but in any case, this is way down the line, but I'm glad some people are looking into it. So with that, let's take a short break, and when we come back, we're either talking about aliens or something even more serious.
If you follow the formula, you will be successful.
Facts.
You will make it. Like,
Yeah.
there's no way that you won't.
Yeah.
So I was like, I'm going to listen to all the advice that I can, figure out what this formula is, and then follow it. Now I'm like interested in learning how to code, and I'm realizing that that program that she did is probably similar to what I would need. So the plan was to spend a few months saving and studying, 3 months of school, 3 months of job hunting, and all of that together put me at a year. Hearing the stories of people who've done exactly what I'm trying to do was very reinforcing. It's not trying to make it to the NBA.
Join today. Get in the action at weareA1.com.
Fast, holding on so we can make it last. 'Cause we got that fire in our bones, taking off on the road. Here we go, oh, here we go. We got that fire in our soul, a little out of control. Here we go, oh, here we go.
All right, wonderful. And we are back to SG2 on Space, the only weekly space show here in Houston, Texas, United States of America. That's probably unnecessary. So, this is episode 20, and I'm your host, Shenga, spelled S-H-E-N, last name G-E, on the wonderful station, or media company, I should say, since we do more than that. Action One Media, right behind me, Action One Media Group. And you're probably listening to us on facebook.com/Action1Media, or on the website, we are a1, the number one.com, facebook.com/here's me, The Shen Show, because that was the old name and I can't change it. Now it's known as SG2 on Space. And, of course, there's also a YouTube channel, which if you go on the Facebook, you should be able to find the link to. So, in this episode, what have we talked about? We talked about, let's see here, an Earth magnetic pole moving super fast. Just a quick summary. Worlds colliding in an exosolar system. Dark energy may be growing in strength over time thanks to new information from quasars astronomers have looked at. SpaceX Starman. Sorry, not Starman. Actually, yes, Starman. Still going around beyond Mars, floating around. Elon Musk plans to go to the moon, as well as go to Mars, and the development of the new type of rocket, Raptor, as well as the Starship, huge spacecraft. NASA's Lunar Reconnaissance Orbiter spotting the Chinese lander Chang'e 4 on the far side of the moon. And talked about generation shifts. How large does it have to be in order for, whole generations of people, one after another, to, take the traditional route of really slow spacecrafts to go to near star system. Any star system. So far so interesting. But, as always, the most exciting part is me talking about crazy alien stuff, right? So I know I kept mentioning the Oumuamua stuff, right? And just as a quick recap, or for people who's new to this, Oumuamua, oh my gosh, that's a funny thing to say, was was the cigar-shaped space rock. That cigar-shaped space rock that's like really long and shaped like that's why I call it cigar shape. Okay, that basically everybody knows it came from outside the solar system. It came in through the solar system and then it exited the solar system, and it was moving really fast. And weirdly enough, not only does it have a weird oblong shape, unlike any asteroid or comet we've ever seen, and not only is it huge, and besides having that weird pencil-like shape, it also accelerated on its way out of the solar system. And we did not see any plumes, so it was not like a comet. So what the heck is it, right? And this, the lead astrophysicist, basically at Avi Loeb, A-V-I-L-O-E-B, from the Harvard astronomy chair, he kept emphasizing that it could be an alien spacecraft, right? Why? Because, as noted, it seemed to accelerate on its own, right? And that a comet could do that if it gets heated by the sun, it causes trapped gas in the nucleus and it expels it, right? Kind of like steam going out of a teapot. But, or like thrusters in a rocket. But there was no sign of outgassing on Oumuamua, so there was something else speeding up. So Loeb, the astronomer, suggested that radiation pressure from the sun itself provided the boost. But for that to work, Oumuamua would have to be very thin, like a sail on a ship, right? So it's like solar radiation, you can think of it like wind hitting a sailboat, right? So you need a thin sail, otherwise it's too massive and you won't move it. So, you know, according to Loeb, perhaps Oumuamua is evidence that intelligent civilization has built pretty much a spacecraft that could sail on the wings of light, let's just say, or light radiation. So, anyways, in a paper he posted last week, well, not last week, I should say a little while back, maybe a month or two ago. He said the model of Oumuamua provides an opportunity to consistently explain its non-gravitational acceleration as effective solar radiation pressure. Okay, the reason I'm emphasizing is that, you know, some of his colleagues in the astronomical world were less than pleased, and they're like, heck no. Okay, well, they didn't say so casually. They actually, you know, provided alternative evidence. So, for instance, Siskana, who is a NASA scientist, Zdeněk Sakanina, suggests that Oumuamua was really just a leftover debris cloud from an interstellar comet that broke apart shortly. Now, Loeb is not buying the idea at all. Now, what does he say? He says, my main concern with the cloud of debris idea is that in order for radiation pressure from sunlight to provide the observed push in Oumuamua, the thickness of the object needs to be less than a millimeter. This would be very difficult to arrange in a natural setup of a porous debris cloud. So, but Sakanina disagrees. So, you know what I think? I think it's aliens. That's the easiest. Stop trying to make up like weird astronomical things that doesn't happen so often, even if it does explain it. It's like, okay, so in fact, Loeb actually had an interview recently with some folks about his. I mean, he had a bunch of interviews, but basically, here's how he explained it. It's kind of like you show a caveman or woman an iPhone, right, or any kind of smartphone. They look at it and they're like, and the other people are like, it's okay. The person, one of them would be like, hey, wait a minute, maybe it's not a piece of rock, maybe it's some glowing kind of rock. All right. So, and that's pretty much what Loeb argued as well, in that, you know, you can't discount all possibilities. I mean, sorry, you can't discount certain possibilities just because you think it's too weird. All right, because that could be the answer. So, speaking of the answer, let's go talk about something even more weird. Did you know? Okay, so you guys know about Bigfoot, right? Since like, I don't think I've ever mentioned Bigfoot ever in this show, because I'm mostly talking about UFOs and life on other planets and stuff if I go there, or life here. Well, okay, I'm going to talk about Bigfoot because there was a Bigfoot conference this week, actually, or early February. And funny, right? Like a Bigfoot conference? Yes, there are conferences where people gather together to talk about their experiences with Bigfoot and gathering evidence on that. So, okay, for those of you who don't know, Bigfoot, according to North American folklore, They're basically hairy, upright walking, ape-like creatures that pretty much live in the wilderness and leave, you named it, I mean, you guessed it, really large footprints. So they're strongly associated with the Pacific Northwest, such as Oregon, Washington, British Columbia. All right, so that's in Canada, right? But of course, people have said they've seen them all across North America. So, you know, in any case, a lot of scientists say, hey, these things are totally fake. They don't exist. Now, how large are they? Well, they're typically, given estimates between 6 to 9 feet tall. They have hair described as black, dark brown, or dark reddish. And the footprints can be as large as 24 inches and 8 inches wide. So, with that much reports about Bigfoot, like, are we really thinking there's people going around making giant footprints? I mean, really? I don't think so. And photos taken. Okay, that aside, what does that have to do with aliens, right? Because the thought here is, even if Bigfoot is real, it might just be some undiscovered ape-like creature. Like, come on, all right? I mean, that's cool, but in my view, not as cool as like aliens, right? Like something from outside this world. Well, there's this father and son pair. So they believe aliens. They've been investigating both Bigfoot and UFO sightings on their Indian Native American reservation with 8 years of data. They have come to the conclusion that the two are pretty much related. So the sightings of these huge dark forms in the sky that move incredible speeds, like UFOs, some of them at least, seem to occur in the same place around the same. Definitely stand out here on Earth, are way less conspicuous than the other kind of alien that tends to be spotted on the reservation, which seems like reptiles. So what does he think? This might be a little wild, but he thinks that the reptile aliens, all right, reptile-like aliens, which everybody would be like, oh my gosh, that's an alien, that's not an ape. So the reptile aliens drop the Bigfoots down onto Earth to do their dirty work, then they pick them up later and drain the Bigfoot's brains. I don't know where he got that crazy idea, but I think it's hilarious. So, yeah. Yeah, there were like 6 million people who attended this conference. I'm kidding. There were only 60 people. All right. Not to make fun of them. It's great that that there's people looking into it. I mean, it's been in popular culture for a while. I'm not sure about his theory that they're like brain drained big apes dropped by reptile aliens, though. That seems a little wild. Who knows, though? We don't know. I mean, they could be related. It doesn't have to be that ridiculous story, though. That's my view. Ridiculous. All right. So, now, on another note that may be interesting, and there's essentially China has apparently become a focal point for alien enthusiasts. So there was a little video of strange aircrafts going across an office building, which is pretty wild. Okay, so I was gonna play this, but and each one is like a different size, which makes it weird because if it's military or commercial, you would think there would be about the same size, but it's not. Alright, and another note, China seems to have its own version of Area 51, which is located in the middle of nowhere in the desert, in the Gobi Desert. And Google Maps, here in the U.S., since Google is a U.S. company, Google can be forced to not show certain sensitive military areas, right? But of course, doesn't have that in China, so internet folks have spotted strange Stonehenge-like circles containing aircrafts in the middle of nowhere in the desert. So what is it? Gosh, who knows? Maybe it's just a secret military base, or could be something else they're hiding, right? Who knows? But if you look online, you can find the coordinates and look at it yourself and decide if those are actual Chinese folks hiding aliens' presence. Wouldn't that be fun? Yes, you should look at it. All right, since you can't look at the Area 51 here, because until the Chinese builds their own satellites, takes pictures, and then reveals it to the public. All right, so wait for that day when that happens. All right, but last note here. I keep telling you guys to look up. Well, I'm not the only one. There's a Brett Harrison Jones, a name that is pretty unspectacular, I would say. So, he filmed a UFO whizzing around in the garden after noticing a flash in the corner of his eye as he was photographing birds. So he was out looking for nature when this pill-shaped thing came in, and this was in Guilford County, North Carolina. Once again, late January 2019, and basically it was at the height of at least a commercial aircraft. So it's pretty otherworldly, so to say. And it pretty much looks like the infamous black triangle TR3B, which TR3B is yeah. So that's a particular type of UFO, which I mentioned before, which looks like a black triangle, right? It makes no sense. All right, so now here's what I like about what he said. He said this. Oh yeah, by the way, that's not the only thing he's seen before. He's also seen silvery triangles in the clouds. He wasn't able to capture that. He also once saw an object at night that looked like a star, but started moving slowly while turning slightly, and then he curved sharply and got really small, so he was moving really fast. So, bottom line is, his words I believe in. He says, I'm always looking up, looking for birds, looking for planes, looking for anything I can see in the sky, such as critters I can photos or videos of. So you know what that means? Yes, you need to look up as well. So, because you never know what you're going to see. You might be like this guy who's looking at birds and then end up seeing UFOs. So that you need to, like, while you're driving your car, yeah, just don't look at the road, look at the sky. I'm kidding, don't do that. But when you're not driving on the road or doing something where you need to pay attention to what's in front of you or around you, look up at the sky, all right? So let me leave it with that, and next week, hear me again. Same time, same place. So, all right, take care, everybody. SG2 on Space, episode number 20 on Action 1 Media.